Welcome all. In this session, we are going to solve a different kind of problem that is known as H index. So let's try to understand what is the problem statement. You are given an integer array that describes the number of citations that a researcher has got for each papers. So let me start with the example. Citations is the name of the array. Suppose it is given as 30615. It means for his first paper he has got 3 citations. For his second paper he have not got any citations. For his third paper he got 6 citation. For fourth 1 citation, and for the fifth paper he have 5th citation. In total he has published 5 papers total. With this information you are supposed to calculate his H index and you have to return it. So let's try to understand what is the definition of the H index. So the definition of the H index is the maximum value of H such that researcher have at least H papers with greater than or equal to H citations. So with this definition and connecting with this particular example, we can tell this researcher have the possibility to get an H index maximum that is equal to the number of papers he is published, that is 5. 5 can be his maximum H index. But let's try to calculate his H index. Since it's maximum, we have to start from the maximum possible scenario. Let's this be the H index candidate, HI. We are going to start from the 5. That is the number of paper he already have. Then the condition we are going to check is that how many papers are there that has a citation greater than or equal to 5. Here there are 2 papers. So we have to write 2 papers. Does this 2 greater than or equal to the candidate which currently we are considering, that is 5? Is it? No, it is not. So this is not the H index. Let's go back to the next candidate, 4. And the question, how many papers are there that has a citation greater than or equal to 4? Here it's again 2. And we are going to ask the question, is 2 greater than or equal to the HI, that is 4? No. So that's also not the H index. Then let's go to the next candidate, that is 3. And the question, how many papers are there that has an H index that has a citations greater than or equal to 3? Here 1, 2, 3. There are 3 papers. And the question, is 3 greater than or equal to 4? Sorry, greater than or equal to 3? Yes, it is. So this is the maximum H index value you can get as per the definition. So we have to return H equal to 3. This is how we calculate H index for this particular example. And how can we solve it? We can solve it in different ways. The first way is by brute force method. So I will explain you the brute force method. In brute force, we are going to keep like track of H index candidate starting from 0 to n, where n is the length of the citation array, n corresponding to length of citation. So each time, each fixed candidate, for example initially we fix hi equal to 0, each time after fixing we will count how many times this have surpassed this particular candidate's count. Then we will count that, and after counting we will check the total number of count, does it surpass this candidate again. Then we will update the hi. I think it would be better to understand while coding. Let's try to code it. So let's write it a bit smaller. So this is the class solution. What is the method inside the class? Method would be h index. So what are the things which is given? Citation array, citations, which is a list of integer. What else is given? Nothing is given. Then we have to return integer. Then I am going to start with first the length of citation is required, length of citations. Then this is the h index candidate starting from 0. Then use the for loop to see how it is getting modified and all. For I in range of n plus 1. So why n plus 1? Because this will take us from 0 up to n, including n. So these are the possible h indexes one could have. So we have to check everything in this particular example. Then we have to set the count equal to 0. Then again do the for loop for c in citations. And inside that, if that c found to be greater than or equal to I, that means yes, this is one possible thing we can count towards. So count plus equal to 1, and at the end, once we have counted, we need that count to verify whether that will satisfy this particular h index to be like a valid one or not. So if that count is greater than or equal to I, okay, in that case the h index would be updated to I. So at the end we just need to return h. So what is happening here? Basically we are going in a reverse fashion. We are starting from the 0 and we will go to up to n, and we are seeing how far we can get and how things by counting this thing. This is a brute force method. So what is the time complexity? Since we are having a loop back to back here, the time complexity is order of n square, and space complexity we are not utilizing anything, so it's order of 1. So is there any better way to solve it? Yes, there is a better way. So there is a solution based on sorting. So that is all about what we have explained here. Once this is sorted in a reverse fashion, we can check this condition and we can arrive at our solution very quickly. We can just do it very fast. We don't need to fix the H index, then you need to vary just like this. We can just do it in this fashion. So the second solution would be a sorting based solution. So solution 2, sorting based. So how we are going to sort? Let me copy the class definition from the other paper. This I need. Copied, pasted here. Let's start. Here first I am going to sort it in a reverse fashion. So that would be done something like citations dot sort reverse equals true. If required, you can write another function to reverse in a like in an opposite fashion, but you can use the inbit function. Then since it is sorted, we are going to calculate the H index in this particular fashion. For example, let's fix H is equal to 0. Now let's go hand in hand with index and the number of citations what we have. So we are basically enumerating the index and the citations together. For I comma C in enumerate citations, and here since the bigger values going to be seen at the first thing, if C is greater than or equal to I plus 1, initially the I would be 0 and C would be something very large. So if we need, we can just see with this particular example. Like, let me copy this particular example and let it be here. We will be erasing it later. If this got sorted in a reverse fashion, then it will be 6, 5, 3, 1, 0. Then the question is, here the C is 6, C equal to 6, and I plus 1 is nothing but 1. Is 6 greater than or equal to 1? Yes, of course it is. In that case, just update the H index to be I plus 1. So in that case, the H index going to become as 1. And next thing, here again C equal to 5. Is 5 greater than or equal to 2? Yes, it is. In that case, H will be updated to 2. Again, in this case, we are asking C equal to 3 is greater than or equal to 3. Is it? Yes, then H will be updated to 3. In the next case, is 1 C greater than or equal to 4? No. That time you can break out. You don't need to do anything. So that's how we are going to solve it. So in that state, once this is done, just break it, and we have arrived at our H index value. Return H. So what is the time and space complexity? So the time complexity here, since we are sorting it, that would be n log n, order of n log n, plus we are enumerating it once again, that would be order of n. If required, you can approximate to order of n log n. Space complexity, we are not utilizing any space, so it will be order of 1. So is it a better solution? Here, yes, there is a better solution, that is solution 3. Like optimally we are going to count it. For that, what we are going to do, we are going to use extra space of array of size n plus 1. Basically this to mention the 0th h index to be 0 as a candidate, 1 as a candidate, 2 as a candidate, and up to n as a candidate. So this have a length of n plus 1. Then what we are going to do is that as we go through the citation array, if any citation that found to have a citation greater than or equal to n, that point, this particular location will be added with 1. But otherwise, if is something like it only has 2 citations, not greater than or equal to n, then that particular location will be added as 1. And after doing this exercise, we will start from the end part, and we will see, we will track a count of number of citations. If that number of citations, total number of citations, is greater than that particular I, then that is the answer. Let's try to understand using this particular example itself. Let me copy this example. And dry run learning is sometimes best to understand the concepts. So I'm going to paste here. How this particular array is going to modify would be here the length is 5. So we will be having an array 1, 2, 3, 4, 5, 6. So here 3. Let me 1, 2, 3, 4, 5. Yes. Here 3. So this will become 1, 0. This will become 1, 6. So this will become 1, 1. This will become 1, 5. Again, this one particular thing will become 2. So like that, this will be modified. And how we are going to do is that we are going to start from this particular thing, and the total is 2. And the question is 2 greater than or equal to I it is 5? No. Then here is nothing is there. Whenever there is nothing is there, is just 0. Is 0 is greater than, so before it's not 0, then 2 plus 0, that is again 2. Is 2 greater than or equal to 4? Again, that's not the case. Then here 2 and 1 will be added, that become 3. Is 3 greater than or equal to 3? Yes. Then return that number h index. So this is working. Just like make this array in this particular fashion, then start counting from the end and have a condition checked in such a way that is the total number of citations gathered so far is greater than or equal to that particular candidate index. In that case, that's the thing. It is working. Let us code it. So it's an exciting solution, because this is intuitively hard to understand, but this is an exciting thing. So let us copy this class definition. I'm keeping it here. I suspect that this might require some more space. So it's better to do in a fresh page. Solution 3, yes. So what I need is first the length information, n is equal to length of citations, then creating that array just the way we wanted, 0 times n plus 1, and then we are going to make that array in the way we wanted. That is, for that, for ch in citations, if ch is greater than or equal to n, in that condition, then count of n to be updated by adding 1, else count of ch, that particular location only, would be updated with adding 1. Then now we have to check using starting from the end of this count. For that we need to have a counter, that let it be total equal to 0. Then for I in range of starting from the index n and up to 0 the index, so it has to be -1 because that will not be included in a reverse fashion. Then we will be adding total plus equal count of I, count only. If the total is greater than or equal to the I itself, in that case return I. That's what we seen in the example. And if nothing happened to be returned, at the end return 0. So that's it. So what is the time complexity? So time complexity here is because there are 2 times independently we are iterating, one to make this array, another to access that array. So it's order of n. Space complexity is order of n because we have utilized extra space for creating this particular array. So with that, I have explained this interesting problem in 3 different fashions. So that's how you calculate h index. So thank you for listening.